Okay, the second example for our critical analysis is up here. So extraneous variables and sample bias. So we're looking at, we're dealing with similar topic to we did in the first question there. So CompuWiz, it's a computer training company. It's the ones the kind that you see advertised on TV. In London, features the profiles of some of the young graduates in a newspaper. So it's an advertisement to get more people to apply for their particular educational facility. The number of months of the number of months of training that these graduates took, their job title, and their incomes appear prominently in the advertisement. So what I've done is I've summarized the data down below in a chart for you. So this comes out of a flyer or some form of advertisement or graphic text that we've been talking about as well. And this is the information that we come from it. So we want to analyze the promotional data using techniques in the class. Well, the techniques that we've learned in the class for this part is dealing with regression and then critically analyzing whether the regression is a valid one for this particular topic. So I'm going to take a moment to enter the data into the graphing calculator, and we'll go from there. All right, I have the data entered into the calculator. So I've got in my x-axis or the L1 column, I have how many months of training. So you're looking at this, and this is not a traditional college that's being advertised here. This is for specific training. So a lot of it looks to be something to do with computers. So when you're looking at the training, the 4, 6, 5, 8, 9 months, it's probably getting updated or upgraded on particular software that companies are using or that form of training. So I'm looking at my data, and I'm looking at nothing seems to go beyond 1 year. So when I go to my window, my x-axis, I'm just going to have it going from 0 to 12, and just doing a monthly analysis. Now I'm going to go back to the list there, and in the other column, the Y column, I'm looking at salaries ranging from 52 to 85,000. So I am going to go. I'll go from say 50,000 to 100,000. And graph it and see what happens. So when I first look at this data that's provided, I notice that it's in that realm of reasonableness. So I'm just going to copy that on there so that I can draw on it. So when I talk about realm of reasonableness, I'm looking at the graph itself and I'm asking myself, is there a correlation? So from the data that's presented, there looks to be some type of linear relationship that could exist there. So it's within the realm of reason. So now I'm going to continue along my way here and come up with a model and see exactly how it's going to look. So going back to stat, I'm going to calculate it. So calculate, oops, that is not what I wanted. Try that one more time. Calculate, I need to go down to number 4 because it looks like a linear regression. And tell it to go ahead and do it. And I'm thinking, wow, that's not too bad. Not too bad. So let's talk about the results here for a second. So from the linear regression, I know that my R value is about 0.9. Okay, so therefore a high correlation, or strong correlation. Sorry, use the right terminology here. Strong positive correlation. So I can get an equation out of this. So y equals, my A value is 5.44, and my B value is 31.9. So where, and I want to make sure I understand what my variables are. Y is the annual income, and X is the months of training. So based on the data provided, there seems to be a strong relationship or correlation between the months trained and the actual outcome or the salary that we're looking at here. So if I go back to the question, analyze it. So we've done that. We've done the analysis. Okay, using B part, use the model created in part A to predict a graduate with 20 months of training. Okay, well we have the model. So 20 months of training. So B part here. What does B part tell us? So if we let X represent 20 months, so I'm just going to do a substitution, and 20 months is just less than 2 years, right? So less than 2 years. So using my equation here, y equals 5.44 times 20 plus the 31.9. Now we can just run that through a calculator, and what we find is that the result is actually fairly significant here. So 5.44 times 20 plus 31.9. That means that the graduate will make $149,000. So therefore, training for 20 months will result in an income of $140,900 per year. All right. So now bells and whistles should be going off in your common sense part of the brain here, because now you're thinking to yourself, well, wait a minute here. If I want to make $140,000, why don't I just go make 20 months of training at this company? So this leads us to C and D. So part C. Does the linear correlation show that CompuWiz's training accounts for graduates' high income? Identify extraneous variables. Okay, when you look at the data down here, when you're looking at what they've advertised in the newspaper, okay, what have they provided? They've provided us with name of the graduate and the field they're working in, months of training with their institution, and what their annual income is now. So the question here is, does the linear correlation show CompuWiz's training? Is it CompuWiz's training that's resulting in this? And extraneous variables, that's like saying, what variables aren't being considered here? So why is that? What is the factor? Because I'm going to tell you right now, if you think you're going to go to one of those sites and you think you're going to come out making $140,000 after 20 months of training, it's not very likely. So what are some of the reasons? So extraneous variables. Okay, so other factors, to put it in layman's terms, other factors. So what are some of the other factors that aren't taken into account here? Okay, so if I'm just going to go get trained on Windows 8, the new Windows 8 system that came out, am I going to come after 4 or 5 months of training, is my income going to go up significantly? Or if I'm going to, what happens if I train for 20 months on Windows 8, is that going to improve it? Definitely not. If you look at some of the careers that we're looking at here, software developer, programmer, systems analyst. Well, I'm going to tell you right now, a programmer, it's going to take more than 6 months to become a programmer. Software developer, so this is a person that writes software. In less than 1 year, you're learning how to write high-end software. What else do we got going on here? Computer technician, learning all about the different systems out there in 5 months. What's happening here is this college or this institution is offering some form of upgrade courses. Those, you cannot get into these careers in that short a time frame or become proficient in them. So some of the stuff that's not being considered here is past experience. Past experience. If someone already has a degree in computer science or a degree in programming from either a university or a college, they're just getting upgraded in a particular piece of software, so they have background understanding. All right. Also, look how many people are actually listed here. So it doesn't seem to be a wide berth of individuals. It looks like they've, specifically picked individuals out. So in their selection, their advertising selection there, specific people were chosen. Okay? Mainly because of their success, which is tied to our previous extraneous variable. So there's a direct correlation there in terms of what the company did. We could be also looking at aptitude. If one person has a knack for what they're doing. If they're very, very good with programming, yeah, they might be a little bit quicker, or they might be able to get into and be successful in their field a little bit quicker. We're looking at social connections here as well. If you know someone, you can get a job. So social connections. Okay. And the list goes on and on. So there's a whole bunch of factors that are listed here. So just because they list, hey, look at these 5 people, look at how well they've done after doing the training, doesn't necessarily mean it was because of their training. It may pay some form of bonus for the person, but it wasn't the sole reason for it. So this is an example of intentional bias. So an example, so this is D part, example of intentional bias. All right, so the intentional bias, they've picked individuals that, the individuals picked, oops, the individuals chosen show immediate and high results. Immediate, and we'll say above average results. So need to be wary of this kind of stuff when you're looking at graphic text in the newspaper and making informed decisions that, you know, even though the statistics, even though the numbers look good, is it reasonable? And what are the reasons for that, the results being the way they are? So that's the second example. We have one final example to go through.